Hello class, welcome to the continuation of our discussion on this topic on kinematics. So this time we will solve at least two problems to illustrate the concept that we have just learned. Alright, so this is the problem statement. A particle moves along the x-axis with an initial velocity Vx equal to 50 feet per second. So initial velocity Vx at the origin when t equal to 0. Then for the first 4 seconds it has no acceleration. Okay, so there was no changes in the velocity, and thereafter it is acted on the retarding force, okay, which gives it a constant acceleration a sub x of negative 10 feet per second squared. And we are asked to calculate the following: the x coordinate, x coordinate of the particle for the conditions t equal to 8 seconds and t equal to 12 seconds. Then find as well the maximum positive x coordinate reached by the particle. Okay, so here's the solution class. We have here the formula for the velocity. So we have the integral of dv equal to the integral of a dt. Then substituting the limits. So initial velocity is equal to 50 as mentioned in the problem. So we have initial velocity, which is 50 feet per second. So we have here 50 as our lower limit. That is the initial velocity. And we generalize the velocity and instantaneous velocity. Okay, so integral of dv sub x equal to, so substituting, we're given the acceleration, which is negative 10. All right, so substituting and then do the integration. So we got here v sub x equal to 90 minus 10 t feet per second. So that is our equation for the velocity in terms of t. And now as plotted here in this graph, so at the specified times, the velocities are the following. By the way, class, this will be plotted now using the information that we have here. So at t equal to 8 seconds, now using this equation, so we got Vx equal to 10 feet per second. So more or less it is somewhere here. All right, so I think it's somewhere here. And then for t equal to 12 seconds, so we got Vx equal to, substituting this value to this equation here. So we got negative 30 feet per second, or this one here. All right. So for the position, so the position is the x coordinate of the particle at any time greater than 4 seconds. So any time greater than 4 seconds, meaning after this is the time 4 seconds. So because there's no change, for within the first 4 seconds there was no change of the velocity, meaning the acceleration is 0. Okay, so if you look at this illustration here, we have a rectangular area, and we know that when you find the displacement, it's just under the curve, the vt curve. So in this case we have the v sub xt curve. Okay, so to find the area, this part here is no problem, because the area here is simply using the formula for the area of the rectangle, that is length times width. So you can easily calculate the area for this part here. But for the other part, we need to integrate. You apply the integration. Okay, so to get the area of this part here. That's why we have here in the formula, so the integral of, so here the distance traveled during the first 4 seconds, so plus the distance traveled after the discontinuity in acceleration, because the discontinuity of the acceleration here is at this point. Okay, so at this point, so beyond 4 seconds, so there's already a change of the velocity, and there's already an acceleration or deceleration. So you see here, it goes down, so it means it decelerates. All right, so we have this resulting equation after you integrate this ds, because we have to find s, the position. So we use x here for the position. Okay, so after integrating, so this part here, 50 times 4, this is just the area of this part, and then plus the integral, so this part here, which is equivalent to this one. Okay, so evaluating this with the limit, lower limit of 4 and the upper limit is t. So we got this. Okay, so at this time, t equal to 8 seconds, so we got this x here, which is equal to 320 feet. Now for 8, meaning up to here, so we got this displacement here. At 8 seconds, the total displacement, so that covers already. Okay, I'll change the color here. So this covers this part already, class. So this area is already included. So take note, displacement is just the area under the curve in the VT curve. Okay, so at t equal to 8 seconds, so this covers this part here and this part. So we got 320 feet. All right, now at x equal to 12 seconds, so at t equal to 12 seconds, so we got this our x here is equal to 280 feet. So meaning from the start up to 12 seconds, so we have this area covered already, as well as this one. Okay, so this can be calculated only using the integral, but actually there's another way of doing it, class, because this is a geometric figures are rectangular, so you can easily find the area also. Okay, so we got here 280. So why is it that after this 12 seconds we have the x? So we're talking of the positive, no, the x coordinate. We're talking of the x coordinate of the particle. So this part is only, okay, that is 280 feet. Okay, now for the by the way, class, this is just the same as in the previous slide. So we go directly to the maximum positive x coordinate. So the maximum positive x coordinate. Okay, so we have for t equal to 12 seconds, so the x coordinate for t equal to 12 seconds is less. So this is less than for t equal to 8 seconds. So the reason is that the motion is in the negative x direction after t equal to 9 seconds. So therefore we can say that the maximum, so the maximum positive coordinate x coordinate is the value of x. So this is the value of x for t equal to 9 seconds. So from our graph, so this is the time here is 9 seconds. So this is 10 seconds here, Okay, and then this is 11 seconds here. So from here, so after this 9 seconds, so the direction is towards negative. Okay, so because below is negative, up is positive. So we can say that uh, the positive x coordinate is the value of x for t equal to 9 seconds. So substituting the value of t, which is 9 seconds. So we have here x max. This is substituting t equal to 9 seconds into the equation of the uh, Vx, resulting, sorry, x, the combination of this area here and also the area calculated using the integral. And this gives us 320 feet. Okay, so the displacement are seen to be the net positive areas under the VT curve, as you can see from this illustration. So you have to take note, or for your practice, you try to show that the total distance traveled by the particle in the 12 seconds is 370 feet. Or you can just look at the illustration here. You calculate area here, plus the area here, then you will get the total distance traveled by the particle. So that is in the 12 seconds is 370 feet. Okay, so try to check that one, plus you just calculate the areas, because the displacement is just the areas under the curve. Okay, now uh, for the other problem, sorry, I interchanged. Now I'm supposed to solve this first, but anyway, uh, this is just the same class. I was supposed to give this problem first. All right, so here is the supposedly the first problem, but now it seems to be the second problem. So the position coordinate of a particle which is confined to move along a straight line is given by this s equal to 2t cubed minus 24t plus 6. So s here is measured in terms of meters, or measured in meters, and from a convenient origin, and t is expressed in seconds. So we need to determine for a, we have to find the time. So what is the time required for the particle to reach the velocity of 72 meters per second from its initial condition at t equal to 0. And then for b, we are required to find the acceleration of the particle when the velocity is 30 meters per second. And c, so we are asked to solve for the net displacement. So what is the net displacement of the particle during the interval from t equal to 1 second to t equal to 4 seconds. Okay, so here's our solution. So we have the velocity as discussed in our previous video. So velocity is just equivalent to the s dot, meaning the dot here indicates, single dot indicates that we differentiate the displacement once, no, with respect to t, and that is equal to v. So from the given, so we're given the function s, no, the displacement as a function of time, which is equal to 2t cubed, 2 times t cubed, then minus 24t, then plus 6. So this is the given function class. Okay, so when you differentiate this with respect to time, so we have s dot. So the dot here, one dot here indicates that we differentiate it once. So this is equivalent to 6t squared. Okay, 6t squared and minus 24. All right, so derivative of constant is equal to 0. So this is our velocity. Okay, velocity is 60 squared minus 24. Then the acceleration, so as you can see here, so this is the velocity. So this one. For the acceleration, you just differentiate this and it will give us this one. Or this is the same as when you take the derivative of this. So you have 2 dot here. So this 2 dot here means that you differentiate this twice, the s, and this gives us 12t as well. Okay, so this is also our acceleration. Okay, so this one is just the same as this. Now plot of the motion. So this is the plot of the motion. So we have to calculate, if you are going to graph this function class, it will give us something like this. Now for the ST curve, so this is the ST curve. Okay, ST curve. And this is our VT curve. VT curve. And this is our A, means acceleration time curve. All right. So solving for problem A. So time when the velocity is 72 meter per second. Okay, so we substitute this value velocity equal to 72 meter per second into this equation and then solve for the time. Okay, so after substituting, so we come up with a quadratic equation. So we can solve for we have two values for t, that is positive and negative 4 seconds. So the negative root describes a mathematical solution for t before the initiation of motion. So this root is of no physical interest at the moment. Thus, the desired result is only this one, t equal to 4 seconds. So that is the answer of our question A. So be alert, no, to the proper choice of sign when taking a square root. So when the situation calls for only one answer, the positive root is not always the one that you may need. So it depends on the kind of problem class. Now for B, so acceleration when v equal to 30 meter per second means the velocity equal to 30 meter per second. So what is the acceleration? So what we're going to do is, again, we have to substitute the value for velocity, which is 30 meter per second, to the equation for the velocity. Okay, so this is the equation of the velocity, but our velocity is given as 30, so substitute it here, then solve for t. Okay, so solving for t, we got t equal to 3 seconds. And the corresponding acceleration is, so you have now the t, substitute the value for t, so you get acceleration that is equal to 36 meter per second squared. Alright, so lastly, we have the net displacement from t equal to 1 second to t equal to 4 seconds. So remember that, as mentioned earlier and also with the previous problem, that the net displacement could be calculated through the curve, the VT curve. We can through the area, no? Calculating the area. So that's represent our displacement. So net displacement. So in this case, we have here the VT curve. This is our VT curve. Okay, so we calculate the displacement using this curve here. All right, so we speak of displacement. So when we speak of displacement, so this is just the delta S. So delta S is equal to S sub 4 minus S sub 1. So it means t equal to 1 second. Okay, so this is our reference time as well as this one. So we have here the position, assuming that the particle is at this point here. So with this distance S sub 1. Okay, and then we have at t equal to 4 seconds, so we have here the time. at 4 seconds. So we have here total time here, the distance, sorry, the distance, which is s. So s sub 4, subscript 4 here means at 4 seconds. So this is the time traveled with the particle. Okay, the corresponding time with reference to this axis. So this is just the same as you're using the equation of s as a function of time. So s as a function of time, so that is given as 2t cubed, okay, 2t cubed minus 2040, then plus 6. So use this as your s, no? You have two s here, s minus s. You have the subscript here 4, so it means your t is equal to 4. Subscript 1 means your t here is 1 second. So substituting, so you can solve for delta s. All right. So delta s, therefore, after substitutions, so we got 54 meter. So that is the net displacement. Net displacement, the delta here refers to the net displacement. Okay, so if you look at the graph, so we have here, this is the displacement from this point to that point, meaning at t equal to, assuming this is the particle here, particle starting from here, it moves from there. So after 1 second, the particle is already here. So it takes a time t 1 second. Then as it moves farther at this point here at t equal to 2 seconds, so this area covered, no, from with this curve and also this horizontal line. So we have here an area. Okay, so this area is negative, that is below, and we also have the time from here, from 2 to, say, from to 3 seconds. So at this point here, okay, and then we have from here goes to 4 seconds. So all in all, from this point here, we have this area. Okay, so we combine this area and this area, so that would be the net displacement. Okay, so the area, this area here, positive area, all right, minus this area here. So overall, so the net is equal to 54 meters. Okay, so I hope it's clear, class. It's clear to you. We have here some comments about the displacement. So to help visualize the motion, the value of S, V, and A are plotted against the time as shown in this illustration here. So because the area under the VT curve, so this is our VT curve, the curve at the middle. So this is our VT curve. So because the area under the VT curve represents, this represents the displacement. So we see that the net displacement from t equal to 1 second to t equal to 4 second is just the positive, positive area. That is the delta s from, so this area here, from 2 to 4, from time t equal to 2 and time t equal to 4. So this is the positive displacement, positive area here. Less, so less means minus the negative area. So the negative area here, so minus the negative area. So this one, so it's just minus, less means minus. Okay, so we got the result here, the difference, that is 54 meters. And you have to take note that from the graphs that the values for V, note from the graphs that the values for V are the slopes, slopes denoted by this S dot, that is the slope of the ST curve. Okay, ST curve. So this is our ST curve, class. So this is our ST curve. Okay, and values for A, so the values of for A are the slopes for VT curve. Okay, so this is our VT curve. So A slopes, the slopes of the VT curve. So suggestion here, So integrate v dt for each of the two intervals and check the answer for delta s. Then show that the total distance traveled during the interval t equal to 1 second and t equal to 4 seconds equal to 74 meters. So you can verify that one, class, by individually integrating using this concept. Okay, so I think that's all, and hope you were able to follow our discussion. And if you have any questions, class, you just send it via GC, or you may comment down below under the video that you will watch from the YouTube channel. Thank you very much. Have a nice day, and God bless everyone. Bye.